Everyone, I have an exciting new nature discovery for you all where recently scientists found that cuttlefish could pass a cognitive test designed for human children. Researchers at the University of Cambridge found that the importance of these findings relate our intellectual ability to these sea creatures, showing us that we should not underestimate their intelligence. Cuttlefish have this amazing ability to adapt to their surroundings, which scientists think is what gave them a bit of an evolutionary push to survive this long in the deep blue sea. So, they put them to the test and created a version of the marshmallow test, which was originally designed for children by researchers at Stanford University. The marshmallow test is pretty straightforward. Basically, a child is placed in a room alone with the marshmallow. Then they're told that if they can manage to not eat that marshmallow for 15 whole minutes, they'll get a second marshmallow, so double the reward, and then they'll be allowed to eat both. Now, this act to delay gratification demonstrates cognitive abilities such as future planning, and it was originally conducted to study how human cognition develops, and specifically at what age a human is smart enough to delay gratification if it means that there's a better outcome later on. Now, because this paradigm is so simple, it can be adjusted for animals. Obviously, you can't just tell an animal they'll get a better reward if they wait, but you can train them to understand that better food is coming if they don't eat the food that's in front of them right away. Taking a deeper look into their study, scientists at the University of Cambridge designed their own version of the marshmallow test. The cuttlefish were placed in 3D printed tanks with 2 transparent chambers so that the animals can see inside. Within those chambers, there were 2 choices of snacks. To the right, a less preferred piece of raw king prawn, and to the left, a much more enticing live grass shrimp. The doors also had symbols on them that cuttlefish had been trained to recognize. A circle meant the door would open straight away. A triangle meant the door would open after a time interval between 10 and 130 seconds. And then the square, used only in the control condition, meant that the door stayed closed indefinitely. In the test condition, the prawn was placed behind the open door while the live shrimp was only accessible after a delay. If the cuttlefish went for the prawn, the shrimp was immediately removed. Meanwhile, in the control group, the shrimp remained inaccessible behind the square symbol door that would not open. They found in the study that all of the cuttlefish in the test condition decided to wait for their preferred food, or the live shrimp, but didn't really bother to do so in the control group, where they couldn't even access it. The study shows that cuttlefish were all able to wait for the better reward and tolerated for up to 130 seconds of the delay, which is comparable to what we see in the field in large-brained vertebrates such as chimpanzees, crows, and parrots. The other part of the study was to test just how good these cuttlefish were at learning. They were shown 2 different visual cues, a gray square and a white one. When they approached one, the other would then be taken from the tank. If they made the correct choice, then they would be rewarded with a snack. Once they had learned to associate the square reward, the researchers then switched the cues so that the other square now became the reward cue. And interestingly enough, the cuttlefish that learned to adapt to this change the quickest were also the cuttlefish that were able to wait longer for the shrimp reward. Looking to the figure here, the cuttlefish show a positive relationship between both of the learning phases. This type of pattern suggests that the subjects are inhibiting previously learned associations, and they are applying a win, stay, lose shift rule. And what that means is that they were able to shift to other responses when their original responses were no longer validated. When this occurs, it is thought that the subjects use their previous experience to develop conditional rules that helps them rapidly switch between contingencies. Positive correlations between both the learning phases just demonstrates an ability to generalize information across reversal problems, and it's indicative of more cognitively demanding modes of learning that just don't solely rely on associative processes. It's clear from the study that cuttlefish can exert self-control, but it's not quite sure as to why. In species such as parrots, primates, and corvids, delayed gratification has been linked to factors such as tool use, food caching, and social competence. Cuttlefish, as far as we know, don't use tools or cache food, nor are they especially social animals. So the researchers then think that this ability to delay gratification might instead have something to do with the way cuttlefish forage for their food. In fact, cuttlefish spend most of their time camouflaging, sitting, and waiting, punctuated by brief periods of foraging. When they need to break camouflage for foraging, they're exposed to every predator in the ocean that can eat them. So, scientists think that delayed gratification may have evolved as a byproduct of this, so the cuttlefish can now strategize their foraging by waiting to choose better quality food. It's quite a fascinating example of how these different lifestyles and different species can result in similar behaviors and cognitive abilities. Future research for these researchers was that they wanted to try to determine if indeed cuttlefish are capable of planning for the future.